Hello friends, how are you? I hope you all are well. Today in this video, I am going to explain one of the important concept of this topic, that is vector addition. Vector addition. I hope that you might have subscribed this channel. If you have not done, don't make any delay to subscribe. As a result, you can get the information in right time when the new videos will be uploaded. At the same time, I hope you will pass this information to your friends. As a result, they can also get the benefit from our channels. So children, without making any delay, I would like to start the vector addition or addition of vectors. Listen carefully. If two physical quantities are similar, then we can go for the vector addition. Similar physical quantities can be added by vector addition. If two physical quantities are similar, then we can do the vector addition, which is completely different from scalar addition. In scalar addition, what we to do? 5 plus 5 is equal to 10. But in vector addition, it is not mandatory that 5 plus 5 will be equal to 10. So this is different from scalar addition. So how it is different? In this video I am going to explain. Let us see carefully. Some important methods are there. Out of that, one is the triangle law of vector addition. Vector addition. First I am going to explain the triangle method of vector addition. What is triangle method of vector addition? So first one is the triangle method of vector addition. Suppose A is a vector, B is another vector. I want to add it by using the triangle law of vector addition. What is the triangle law of vector addition? Let us see. Suppose OA, this is one vector. AB, another vector. This vector OA, suppose this is A vector, this is B vector, or I shall prefer to use the small letter, vector A, vector B. Here, vector A, OA, vector B, that is AB. Okay. So, I am writing this is B, this is A. See. Now, these two vectors are arranged in such a manner, it is representing the two sides of a triangle. Then the resultant vector will be the third side. The resultant vector will be the third side, but in opposite order. That means here O to A is the vector. This point A is the head or the tip of the vector, where O is the tail of the vector. The vector B, that means AB, here second vector tail coincide with the head of the first vector. That means vector A and B are taken in same order. This is the order. But the resultant vector not in the same order. The resultant vector is in opposite order. That means the resultant vector tail coincide with the tail of the first vector and head coincide with the head of the second or the last vector, what you can say here. Okay, so I can say that if two vectors are completely represented by the two sides of a triangle. If two vectors are completely represented by the two sides of a triangle taken in the same order, then the resultant vector is the third side of the triangle taken in opposite order. This is the triangle of vector addition. This is the resultant vector. R is the resultant vector. So I can say that this R is equal to A plus B. R is equal to A plus B, or I can write here it is OA plus AB is equal to R, which is equal to O to B. Okay, this is R. So now let us move to calculate the magnitude and direction. The magnitude of the resultant vector and also its direction. See here children, this is OA vector, this is AB vector. How we will calculate? Now I am going to explain. See. Okay, see here. Once again, I am drawing it here. This is O, this is A, this is B. Okay. Now this is A vector, this is B vector, this is the resultant vector. Now I am extending it. See here. This is B. From here I am drawing one perpendicular. Okay. Suppose this is A. Here this angle is theta. This angle is theta. Now let us see. Now OBN or ONB is a right angle triangle. So we know that in triangle ONB, right triangle ONB, right triangle, I have drawn the perpendicular. OB square is equal to ON square plus BN square. That means square of the hypotenuse is equal to sum of the square of the other two sides. So in place of ON square, I can take it OA plus AN square plus BN square. This is equal to A plus B whole square. So OA square plus AN square plus 2OA into AN plus BN square. Let us see here. Now in this small triangle A and B, we know that AB square is equal to AN square plus BN square. See here, AN square plus BN square, because this is a right angle triangle. AB square is equal to AN square plus BN square. So here I am writing OA square plus, in place of AN square plus BN square, I am writing AB square. AB square plus 2OA into AN. The fact is that what I did here AB square is equal to AN square plus BN square. So let us see here. So this is OA square plus AB square plus 2OA into AN. Now you say that in this triangle, if I take the cos theta, see here, cos theta is equal to B by H. That means AN by AB. AN by AB implies that this AN is equal to AB cos theta. Similarly, if I take the sin theta is equal to P by H. In this triangle, AB divided by, this is BN divided by AB. AB implies that BN is equal to AB sin theta. So now what I can do? Now I can say that this OB square, now OB square is equal to OA square plus AB square, OA square plus AB square plus 2OA 2OA into AN. In place of AN, I am using AB cos theta. AB cos theta. So now I can make it OB is equal to OA square plus AB square plus 2OA into into AB cos theta. It says square root. Or I can say that the magnitude of the resultant vector are equal to, I can write like this way. This is A square plus B square plus 2AB cos theta. This is the magnitude of resultant vector. This is magnitude of resultant vector. Then what about its direction? Now we'll see about its direction. Let this angle is phi. Let this angle is phi. Then I can say that this tan phi is equal to P by B. That means Bn by On. This is Bn divided by On. P by B. Bn by On. So, in place of Bn, we can write AB sin theta. This is equal to AB sin theta divided by ON. In place of ON, I can write OA plus AN. So OA plus AN. In place of AN, I can write AB cos theta. AB cos theta. Or shortly, I can write that. So here AB, that means B sin theta divided by A plus B cos theta. This is the direction. So if I wish, I can mention it. Phi is equal to tan inverse B sin theta divided by A plus B cos theta. Once again, I would like to write it here. So tan phi, we got B sin theta divided by A plus B cos theta. This is about the direction, and this is about the magnitude of the vector according to the triangle law or triangle method of a vector addition. I hope that this concept might be crystal clear for you. So I'm expecting you might have copied it. So I shall go to the next law, that is the parallelogram law of vector addition. This is about the triangle law. Next one is the parallelogram law of vector addition. Okay, children? This is triangle method. Next one is the parallelogram method of vector addition. That means, see here. So this is the vector A, this is the vector B. Suppose it is represented by the two sides of two adjacent sides of a parallelogram. So OA, this is vector. Now this is another vector. Listen carefully. These two vectors, for example, this is the vector A, this is the vector B. In my previous explanation, I explained by taking it as the two sides of a triangle. Now I am taking it as the two adjacent sides of a parallelogram. There is not much difference. That is triangle, this is the parallelogram. So, if the two vectors are represented by the two sides of a parallelogram, then what will be its resultant vector? So I am writing here, if two vectors are represented by the two adjacent sides of a parallelogram, then the resultant vector is the diagonal of the parallelogram whose initial point is the point of coincide of the two given vectors. The point of coincidence of the two given vectors. That means, so somewhat left I shall draw it. See here, this is the vector A, this is the vector B. Now listen carefully. I am completing it. I am completing the parallelogram. See here. So now this is the diagonal, which is the resultant vector. So I am giving its name as, okay, so I shall write it as C, I shall write it as B. It will be somewhat comfortable. Now you see that this is a parallelogram. These two sides are the opposite sides. If this one is the B, ultimately this is also B. If this is A, ultimately this is also A. So now I can write like the triangle method of a vector addition, because I have taken the vector A and vector B are the two adjacent sides of the parallelogram. So these opposite sides are also equal. This is also B, this is also. So now I can write this resultant vector. This resultant vector R is equal to A plus B, or its magnitude I can write R equal to A square plus B square plus 2AB cos theta root over, and its magnitude also like the previous result we got. And what about the angle? And if this angle is equal to phi, then I can write this tan phi is equal to B sin theta divided by A plus B cos theta, like the triangle law, because I converted this two sides as the sides of a triangle, because in vector if we shift this one in parallel or like this shift, there will be no change in the vector. What is here, I can make it here, I can make it here, I can shift it parallel. What I shall discuss more in my upcoming videos. So this is about the magnitude and this is about the direction, just like the triangle law. Let us see one more method, that is polygon law of vector addition. Polygon law of vector addition. What is polygon law of vector addition? Suppose you see that OA is a vector, AB is a vector, BC is a vector, CD is a vector. I have taken 4 vectors here. Number of vectors, if it is representing the sides of a open polygon, then the resultant vector is a vector, but that is in opposite order, whose tail will be the tail of the first vector and whose head will be the head of the last vector. So I can write that if number of vectors are represented by the sides of a open polygon, taken in the same order, then the resultant will be a vector whose initial point is the tail of the first vector and terminal point is the head of the last vector. That means in opposite order. Let us see here. For example, I am writing OA plus AB plus BC plus CD. The resultant vector is OD. The resultant vector is OD. Now, let us see that suppose OA plus AB plus BC plus CD plus DO. This is equal to OD plus DO. Both sides I have added DO. OD and DO both are equal in magnitude but opposite in direction. That means see here. Okay, then what I can write? I can say that OA plus AB plus BC plus CD plus DO is equal to 0. Since OD equal to minus DO, OD equal to minus DO. So another way I can say that if vectors are represented by the sides of a polygon, then their vector sum is 0. Let us see here how I am writing it. This is the alternative law, you can alternative way I can express. If the vectors are represented by the sides of a polygon. Listen carefully. I have written OA, AB, BC, CD and DO. I have written here DO. So if the vectors are represented by the sides of a polygon in a order, then their vector sum is 0. So this is about the polygon law of vector addition. Let us move some special cases. What is about the special cases? So I hope that you are understanding the concept clearly. If anything, you can comment on my video. As a result, in my next video, I may clear your doubts. I shall try my best. So, what are the special cases? We will see. Special cases. What are the special cases? First one, for example, the vector A is parallel to the vector B. If vector A and B both are parallel, then I can say that this R is equal to A square plus B square plus 2AB cos theta. That means it is equal to A square plus B square plus 2AB. Listen carefully. So, or I can write that, this better I shall write it. Okay. So, in this case, what I can write? I can write this is A plus B whole square. That means this is equal to A plus B. Listen carefully. I have taken A and B are parallel. That means cos theta is equal to 0. Since A theta equal to 0, so cos 0 degree is equal to 1. So in place of cos 0 degree, I have mentioned 1. That means the R is equal to A plus B. R is that means the resultant vector is just simply addition of the two given vectors. So this is about the case where A and B are parallel. So in this case, the R will be maximum. That means the R maximum is equal to A plus B, because in cos 1 is the maximum value. So I have written that is R maximum is equal to A plus B. Then what about the tan phi? Tan phi is equal to B sin theta divided by A plus B cos theta. Previously got this is equal to B sin theta divided by A plus B cos theta. Okay. Then if sin theta, theta I have taken 0, sin 0 degree equal to 0, that means this is equal to 0. That means I can say that this phi is equal to 0. Okay. So R will be maximum, that means A plus B. That means when the cos theta will be equal to 1. This is the case when the cos theta is equal to 1. Okay. And in that case tan phi will be equal to 0, or I can say phi equal to 0. This is the case of a parallel. So one more case we will see. Suppose vector A and B are perpendicular. If it is perpendicular, then what will do? R is equal to A square plus B square plus 2AB cos theta. That means the cos 90 degree. So I can write this is equal to A square plus B square minus 2AB, since cos so A and B is equal to perpendicular. Sorry. So this is 2AB cos theta. So this will be equal to 0. So in cos 90 degree is equal to 0. So I can write that R is equal to square root of A square plus B square. What about the tan phi? We can write tan phi is equal to, so in my previous case I explained that this is equal to tan phi is equal to B sin A sin theta divided by A plus what I mentioned, B sin theta divided by A plus B cos theta. Okay, this is tan phi. So if this is equal to 90 degree, so ultimately the sin 90 degree is equal to 1. So I can write this is equal to B by A. Why? Because 90 degree is equal to 0, sin 90 degree is equal to 1. So I can mention it, tan phi is equal to B by A. This is the case of the perpendicular. So what about the anti-parallel? If vector A and vector B are anti-parallel, for example anti-parallel, that means the theta is equal to 180 degree. In this case we will write that R is equal to A square plus B square plus 2AB cos theta. Here theta equal to 180 degree, that is equal to minus 1. So I can write that this is A square plus B square minus 2AB, since cos 180 degree is equal to minus 1. So we can write it A minus B or this is A minus B. This is the magnitude. So what about the direction? So I can mention that tan phi is equal to B sin theta by B sin phi divided by A plus B cos phi. Okay. So this is equal to 0. That means the phi becomes it may be 0 or it may be equal to pi. So in this case, let us see that suppose if A is greater than B, that means I can say that this resultant A minus B, it will be positive difference. With positive difference. If A is less than B, then the rate R will be equal to B minus A. So this is about the some of the special cases I said. So in my next video, I like to explain about some of the properties of the vector addition and many more things in my upcoming videos will come. I hope that you enjoyed this class. Until the next video,